Okay, so now let's look at this question. Which one of the following well-formed formulae is in predicate calculus is not valid? Not valid. So among these four, three will be valid, one will be not valid. That we have to find out. Okay, so the first one, A, is basically what? For all x p. Okay, for all x p, so something, it is something like this, implies for all x q. Is it the case? So for all x p is there, then for all x q is there. I can write it something like this, that okay, not of for all x p or for all x q, and this not can be inserted inside, then for all will become there exist not p or for all x q, and what is here, there exist x not p or for all x q. So basically this thing is definitely implying, so I can definitely say that this thing is correct, rather implying it is rather equivalent, so definitely. Okay, so what about B? B is there exist x p or there exists x q. Okay, so obviously there exists some x for which px is true, or there exists some x for which qx is true. Then I can definitely say that there exists some x for which p or q is true. Why? Because okay, so I have at least one element for which p exists, so there is not even need to go here. Then definitely I have at least one element where this is true, so this or this, anything doesn't matter, q, but even there exists one element for which p is true, so this is true. So in that sense you can see that here also there exists p or q, this thing is also correct. What about C? C. In C they are saying that there exist x, p and q. Now this is different. See, they are saying that there exist x, there is one x for which px and qx, both of them are correct, right? So what does it mean? It definitely means that I can say two things, that there exists x where px is true and there exists x where qx is true, and both are correct, right? So after that I can say that since this thing is separately correct and this thing is separately correct, then I can imply that it means that there exists x p and there exists x q. If I take and of both of them, then that thing will also be correct, because individually I can claim that both of them are true. So C is also implying correctly. What about D? So D should not be valid, right? D should not be valid because all the three ABC are valid. Let's check that D should be valid or not. Okay, so for all x, px or qx imply, so they're saying that for all x, p or q. Okay, so for every x, either p or q is true. Then can we say something like this, that it implies for all x p or for all x q? We don't know this, you have to find out. Now turns out it is not the case. I'll give you an example for that. Let's say for x is equal to 0, okay, px, so let's say p0, this thing is true, and q0, this is false, so this thing is false and this thing is true. I'm not writing anything, it means true, false I'm writing. Okay, and let's say for x is equal to 1, okay, p of 1 is false but q of 1 is true. Okay, that is the case. Now does the left hand side hold or not? Firstly tell me. See, for all x, p or q, so for this x, among p or q, one of them is true, isn't the case? Yes, and that's why p or q is true. So true or false, it is true. For x equal to 1 also, false or true is true. So for every x equal to 0, this or thing is true. For x equal to 1, this or thing is true. So for all x, p or q is true, every x. But what about for all x p? For every x equal to 0, x equal to 1, for every x, is p true? No. One time it is true, one time it is false. So this thing is false. Similarly, this thing is also false. Here you can check, right? One time true, one time false. And false or false is false, right? So the left side is true and right side is false. So basically this is standard way of saying that this thing is not valid. So we have proved that this thing is not valid. So which one of them is not valid? And we had to pick an answer. So the correct answer is D.